Okay, so this video is going to be on at least probability. And by that I mean questions when you're asked like, what is the probability you get at least one red marble out of the barrel, or at least one defective, or at least two defective machines in your order? Okay, so just to give an example of the kind of question we could be looking at, let's say you pick 15 cards from a deck. What's the probability you get at least one ace? Well, here's the problem with events. In event E, we use capital E sometimes to stand for an event. When there's at least something, there's a lot of ways sometimes of satisfying that condition. For example, you could get one ace in your hand of 15 cards, or you could get two aces. And those are separate ways you could satisfy that. Or you could get three aces, or you could get four aces. You couldn't really get any more than four unless the deck is messed up, because there's only four aces. So they give us four different methods of satisfying at least one ace. So a lot of times we say, well, that's going to be a little confusing. It's not impossible. I'll show you how to do it directly here in a minute. And if you're using Excel and you set up your spreadsheet kind of cleverly, you can just drag things down and do a whole bunch of calculations very fast anyways using probability. So it's certainly not impossible. But there's often an easier way to do it if we look at the opposite problem. So whenever you're facing a kind of an at least, you want to think, what would be the opposite of this? And what is the opposite of getting at least one ace? So the question is asking, how could you fail to get at least one ace? Well, the opposite of getting at least one ace is getting no aces. You either get no aces or you get at least one, or you get some aces. So since those divide the probability into two different things, you either get one or the other and there's no intersection, we know that the probability of at least one ace plus the probability of no aces has to equal 1. You get one or the other of those two conditions. So now you could actually calculate this directly. In the first card you pick, there are 48 cards in the deck that aren't aces, because there's 4 aces. So 48 over 52. You say, okay, well that one's done. Now after that happens, what's the probability the next card is also not an ace? Well, after you've picked one card, there's 51 cards left, of which 47 are not aces, because you grabbed one of the not aces, and you could go all the way down, putting 15 of those together. So that's a direct calculation. But if you've watched the other video that introduces the cominatorics NCR on the calculator, this will make our calculation considerably easier. So here's the sort of the shortcut way of doing this. 48, choose 15. So I want 15 cards out of the 48 non-aces. Now I put in the 4 NCR 0. I want 0 from the aces. You wouldn't have to have this. 4 NCR 0 evaluates to 1, so it'd be 1 times something, and it would make no difference to your calculation. But I generally do put this here because of the form of the problem looks cleaner to me this way. Now, if we don't care at all where we get the cards, then we're picking 15 out of the whole deck. So that's the whole world, and then this part here is where we're seeing what we want to have happen. So 52, choose 15 on the bottom. Now, the reason I like this is because 48 plus 4 is 52, 15 plus 0 is 15, and you can always see this in your space. You're breaking up, you're picking what you want, and you're deciding how you're going to pick them. So 15 out of 52, I don't care at all, but here I'm putting those 15 where I want them, 15 in the non-ace cards and 0 in the aces. And that evaluates to 0.24395 if I copied this properly for Wolfram. You can do these calculations on Wolfram. You will need to put a parenthesis around each NCR pair. It reads it funny. You can do this on your TI-83 using second probability and NCR, and then you don't need the parentheses. So that's a minor difference, but not a big deal. Now we have to remind ourselves, this is not our answer. This is what we don't want. This is the probability of 0 aces, so I subtract that from 1 to get my actual answer to the problem. Now, there is a direct way to do the problem. You could say, well, I'm either going to get 1, 2, 3, or 4 aces. I mean, we already addressed the 0. And those are all the separate ways of getting at least one ace. And this actually makes what's called a partition of the space. You either get 0, 1, 2, 3, or 4 aces. Those are all the possible answers, and there's no intersection. You can't get 2 and 3 aces at the same time. It's one or the other. So the probability of all 5 of those, 0, 1, 2, 3, and 4, if you calculated each one of them, have to add up to 1. And we're interested in the last 4. So using cominatorics again, and this will actually, I wouldn't really do this problem this way myself, but it gives a good review of what we're doing with the cominatorics. I could say, well, what's the probability I get 1 ace? 1 from the 4 aces, 14 from the non-aces over 52, choose 15. Plus, what's the probability I get 2 aces? Well, then there's 13 from the non-aces and 2 from the aces. And so each time we're deciding where our 15 cards are going to come from, and so we pick, 3 aces and 12 non-aces and 4 aces and 11 non-aces and so on. We do each one of those 4. So it's a little bit messy. It's a little more work. If you're fast with your calculator, you could do one calculation like this and do second entry, which gives you this form to work with again, and just move over with your cursor and change the 1 to a 2 and the 14 to a 13. hit enter again and write down another number. So you could honestly do this pretty fast, even in this longer method. So it's not impossible. And then if you set this up on Excel and made the 1, 2, 3, 4 down a column, you could do it all very quickly. It would actually be pretty easy on Excel to make a long chart like this, an even much longer one. So it's not impossible, and it's certainly not wrong, giving you a lot of alternatives. I think the opposite is easier. So that's my technique, but you're certainly welcome to get to your own level of efficiency to get the right answer to this any way that you like. So hopefully that video has been helpful, and I've had a lot of questions on at least probability, a lot of people saying I did it exactly right, and they're actually calculating the probability of exactly one, not at least one. So hopefully that's helped to clarify it.